Today we'll be talking about bamboo, unorganic material. First of all, what is bamboo? Even though it may seem like it, bamboo is not a type of tree. It's actually a type of wild grass, and a very resilient one at that. That's in part due to its flexibility. Even though it may seem rigid, bamboo has to be flexible in order to withstand high winds. It's also very abundant. It grows in various tropical regions of the world, and it is sustainable. We will get into why we can call it a sustainable material in just a little bit. There are approximately 1,450 different species in the world, and out of all those, only 7 are used primarily today. Why can we call it a sustainable resource? Well, for one, growing bamboo in the right conditions is relatively quick. New shoots of bamboo produce each year, and those shoots can grow up to 1 meter in the span of 3 days with appropriate water, with appropriate sun. And like I said, they can adapt to various climates. So they can also grow in deep ravines, mountainsides, and other difficult to farm locations that otherwise wouldn't be used to grow anything else. Like other types of grasses, trees, plants, and animals as well, it's biodegradable. The day that a bamboo tree or a bamboo plant, bamboo grass, sees the end of its life, it'll drop to the bottom of the forest floor and be decomposed, and its nutrients will return to the earth. It adapts to various climates across 122 countries and distinct islands and regions. And it only takes about 3 years to reach maturity, or when it can be harvested for use. Bamboo has been used expansively in tropical civilizations for the thousands of years. And it can also be said that it aided in the spread of humans as well as cultural diffusion, because even though a lot of the boats in textbook images are going to be made of wood, steel, a combination of those, early rafts and boats from tropical civilizations used bamboo. And those rafts and boats took them to islands who were previously uninhabited, where they made more civilizations, where they could spread their culture, diffuse culture with other civilizations, etc. It has been the focus of study in different eras. For example, in the 3rd and 4th century, the Qin dynasty of China studied its botanical properties. And then later, much later, in the 19th and 20th centuries, the mechanical properties of bamboo began to be studied. Next, we'll take a look at a couple of applications. The first of which is bamboo scaffolding. It isn't seen at all here in the United States, but China still uses bamboo scaffolding. And as you can see in the image that's being used as the background, it's not for small buildings. It's for multi-floor or multi-leveled buildings that they still use bamboo scaffolding, which is actually a pretty impressive sight, even though it's only a picture, it's only an image. The layer of complexity is slightly increased because metal scaffolding, you could join one metal rod to another with bolts, welding it, other forms. But both of those ways, which are very common, bolting them and welding them together, can't be used with bamboo. So for each connection is a little bit more laborious because they have to be made with a combination of metal bracing, twine, rope, and other materials. However, on the other hand, the pace of assembly and disassembly is increased because bamboo being hollow and relatively lightweight to metal means that it's easier to be handled by people. And also, if it's less heavy, more of it can be brought per truckload. So if you have enough workers and you have more being brought per truckload, then its assembly and disassembly speed is going to be quicker. Also, like we said, it has to be flexible to withstand the winds when it's in the forest. So that quality is retained when it's used for scaffolding. The bamboo scaffolding will actually flex when winds come into the city, and it's a visible bending that occurs. The second application we'll take a look at is basket weaving. Basket weaving of bamboo is in part due to the fibrous nature of it, which lends itself to basket weaving. This had extreme importance before industrialization because things like plastic buckets, thin metal buckets weren't accessible to people, out in rural areas. Today, basket weaving made from bamboo is still valued as an art piece, as well as everyday tools in communities that are still isolated to this day. They're easily split into strips with simple tools by experienced craftsmen. Even though wood can also be split into strips because it is fibrous in nature as well, but the way that bamboo is made, the way that bamboo comes out of the ground, it lends itself a little bit more to be made into strips. Bamboo, like all things, has its limits. For one, it's highly anisotropic. Like we said, it's made of fibrous material. So the way it's going to react when forces act on it uniaxially and transversely vary a whole lot. Even though it's resistant to it, it can be targeted by insects and other animals that eat it. And it is also inherently inhomogeneous. And what that means is those fibers run from top to bottom. But the properties of those fibers might differ from top to bottom. For example, the tensile strength of bamboo differs when you traverse it from top to bottom. For example, near the top, if we divided a rod of bamboo into thirds approximately, the top third has a tensile strength of 325 megapascals, the middle of 400, and the bottom of 425. And that is because it varies in outer thickness as well as wall thickness. And as we know, those are two huge factors when it comes to tensile strength. For comparison, I put the tensile strength of some metals. So we can see it is in the neighborhood of the tensile strength of aluminum alloys as well as titanium alloys. Bamboo in the future. Well, as I said before, out of the thousands of species of bamboo, a very small amount is being used. There are a lot of different bamboo species or bamboo varieties with different properties to be explored. And as more of them are explored, more uses can be found for bamboo. Selective breeding that can be performed on bamboo can encourage certain characteristics that may be desired. For example, a thicker wall, or less density, or a longer comb length. Better regulation of structural bamboo can expand its use as well. Like we said, it's highly anisotropic and inhomogeneous. So when it's used for things like scaffolding, workers have to keep an eye on the discrepancies of the properties of one bamboo rod to another, because it can be very unsafe. If one bamboo rod has some section that came damaged the way it grew, then that could mean a scaffolding coming to the ground. So better regulation might lead to bamboo being used structurally in more places around the world.